This top plate is printed from this polycarbonate and acrylic mix, and I have a test where this material performs the best so far from all materials I tested. Try to guess which property is that. Hello, welcome to my tech farm. Again, new filament type on this channel. This is Verbatim Durabio 3D printing filament, mix of PC and PMMA, polycarbonate and polymethyl methacrylate or acrylic. And the cost of this filament is approximately $46 for half kilogram spool for me here in Europe, and I bought it from the budget which I got from the polymaker, who became a channel sponsor. I couldn't find any information about the ratio of these two materials, but let's see some other specifications mentioned on the website. Excellent optical and mechanical properties, and both materials, polycarbonate and acrylic, are very transparent materials, but of course 3D printing technology is not. We will always have those gaps which will break the light, and the final object is not so transparent. High heat, scratch and abrasion resistance, and most of this I'm testing, so we will see that in this video. UV resistance, so it is good for outdoor applications. Let's see some print settings. On the nozzle 230 degrees Celsius plus minus 10, on the bed 100 degrees, speed 50 mm per second. This is very low speed, and I'm not sure is it just old data they didn't update it, or it really requires so low speed. Fan 50%, and enclosure is not needed. And what I'm missing here are the information, so what bed build surface should I use. I will try with textured PI sheet, maybe without any glue, but if it will not work, then I'm moving to the engineering plate with the glue on it. It works with the polycarbonate, I know, I tested this earlier. Actually, Verbatim made a filament from Durabio, but Durabio itself is a material developed by Mitsubishi Chemicals as a glass substitute. It is very scratch resistant material. Information and warranty. Okay, I never saw that. Not really vacuum packaging, or partly. The bag is resealable on longer side. Yes, the filament itself is very transparent. Almost no useful information on the sticker, except that the spool is made from the ABS. This may be useful information for the drying, but for example on the website I don't have any information about the drying of this filament or moisture sensitivity. The filament is not too brittle, but not too flexible neither. Maybe I can even break it. Fatigue. Okay, interesting. I don't understand. The manufacturers don't use their own spools. For example, this is the end of the filament, and look how much waste I have because I have to bend it here. At least distance between the holes should be a little bit bigger, so we have less bending of the filament. And look at this, the spool is only half kilograms, but it is too wide for the AMS. They should definitely rethink the size of the spool. So it has to go to the external spool holder. Quick check if the filament is dry, extruding a little bit. And when it stops with the extruding, cut. Not bad, very minimal oozing. Okay. I will use it without drying. It looks okay so far, but quickly to check with the purge line. On the edge of the acceptable. Probably I'm moving to the engineering plate. It just finished the printing. The bed is still hot. No, they should be stronger. Okay. If I have to use the glue, then I'm moving to the engineering plate. I still want to check the bed adhesion, but I'm printing some overhangs too. Oh, okay. This is strong. Definitely have to wait until it cools down. Very transparent filament, and this overhang came out quite good too. So I think I have my final slicer settings. Slicer setting, I made this profile by modifying the polycarbonate settings. Chamber temperature 50 degrees Celsius, bed 110, 240 will be the nozzle temperature, and the flow rate 6 cubic millimeters per second, and this is the maximal part cooling of 50%. And these are my typical test objects. Same specimens I used in my earlier videos too. The start is good. This is now the 7th layer, and reminder for me, with the engineering plate I have to place the glue under the purge line too. Nice and clean print even at the end with these vertically printed objects, And those overhangs looks nice, but I will analyze that later when it's printed. That overhang is really nice, absolutely no warping, and look how transparent is this material. Far more than PTG. Of course, with FDM printing we cannot get full transparency, but very interesting property. Currently I'm not sure is this a good example, but this object I need for the partial transparency. By the way, this is now the smooth PI sheet without any glue, and I already checked with the press line. It really has a nice adhesion to this material. For my future transparency comparison video, a cylinder printed in spiral mode, 40 mm in diameter and height, and all walls are set to 0.5 mm. In the meantime I printed a few other test objects. These are for the wearing test, and actually this smooth PI sheet without glue works better than the engineering plate with the glue. Good to know. Open-end wrench from my previous video. This object I use in educational purposes to explain how durometer works, measuring the shore hardness. For example, with the harder object it moves completely up. With the softer object the needle penetrates a little bit, and as you can see it moves a little bit less. Now the problem with this is that it is open, and sometimes if I give this to students it falls apart and then I have to assemble it. But I didn't want to cover this, I needed this open. And now finally I have the solution for this. So this is printed from this PC-PMMA or acrylic. It is 0.6 mm thickness, this means 3 layers. And it is not fully transparent, but clearly we can see what's happening inside. The wearing test with 3 mm diameter shaft, and the load is 2.5 kilograms. This is the start of the testing. And this is the end after 200 repeats. And not only visually, but also nothing for the touch. I already mentioned that this was one of the aim by Mitsubishi Chemicals, so I could be prepared, but it still impressed me. This is how usually object looks like after this test, but on Durabio no any kind of scratch marks. More scratch resistant even compared to the nylon or TPU. I measured the shrinking, which is in this case approximately 0.5%, which is very typical for the ABS material, for example. Tensile test with horizontal printed object. I'm not sure which material to include here, so I decided average polycarbonate, and I have 14 pieces in that summary table, all without fibers. And we can see that the Durabio is a little bit weaker compared to the average polycarbonate in the tensile test. But this is not bad value, something like PLA for example. Layer adhesion with vertically printed test specimen. This is my rating for this type of the test object, and we can see that this filament has a great layer adhesion, very similar to the average polycarbonate. Shear test side by side horizontal in vertically printed objects. In both cases these are very good numbers, especially for the material without fibers, and again in both cases it was a little bit stronger compared to the average polycarbonate. Torsion test starting with horizontally printed part. 1.7. Printed in vertical position. 1.6. These are great values, and in both cases it was stronger compared to the average polycarbonate by approximately 20%. Grip test the deformation under constant load, and I have several tests in the progress: PPACF, PC Acrylic and PPS filament. The load is 1.25 kilograms. $16.53. It's the last fifth day of the measuring. 17.29. Removing the load. On this graph we can see the distance between two reference surfaces, and we can see a little bit more deformation on this Durabio filament compared to the average polycarbonate, but the creeping is the difference between 2 days. Well, here I am recording only first 2 days, and we can see less creeping on this Durabio filament compared to the average polycarbonate. Temperature test in the oven. I want to record the temperature of the first deformation, And the average value for the polycarbonate is 125 degrees Celsius, but this Durabio is closer to the carbon fiber ABS in this case, and started to deform at 95 degrees Celsius. Sharp impact testing. Replacing the hammer, preparing for the ISOT impact test. Taking a picture for the documentation, and now the results in the top upper corner for the Sharpie and for the ISOT. And maybe the only weak point of this material that it is brittle, very similar to the average PETG, for example. 3-point bending test, distance between supports is 50 mm, and I'm placing these loads one by one and measuring the deformation after 1, 30 and 60 seconds. Currently this is the deformation under 5 kg and under 10 kg. Now let's analyze the data. Very similar deformation at the beginning, a little bit smaller on the average polycarbonate, but look at this, under 10 kg, this Durabio handled better this bigger load compared to the average polycarbonate. Less additional deformation during that 1 minute. All results one more time: creep test, tensile and layer adhesion, shear test horizontal and vertical, bending test deformation after 30 seconds, bending test deformation after 1, 30 and 60 seconds, torsion test horizontal and vertical, temperature test, and the impact test. After I solved the problem with the bed adhesion, I started to like this filament, and even if it is not cheap, but this is quite unique property, transparency and wear resistancy, and I decided to buy one more filament because this is only half kilograms, and I noticed that it is hardly available now, and I wrote directly to the Verbatim support an email. Next morning they answered me, and unfortunately they told me that in December 2025 this filament is discontinued. So I apologize for this. I presented you the filament which probably you cannot buy anymore, but I hope that we learned something. I find this filament very interesting, and maybe I will try to buy some other acrylic filament because very interesting properties of this material. And I don't know, if you have some other experience, few lines down in the comment section. And big thanks to the Polymaker and to my Patreon supporters, because thanks to their donations I can create even this kind of videos. Maybe it is better if the company is sending me the filament, because at least they know that it will not be discontinued. But anyway, thank you for watching this video until the end, and happy printing.